Okay, new chapter. Section 8.1 is multiplying monomials. So what is a monomial? A monomial is a number, a variable, or a product of a number and one or more variables. So you've seen them before. For example, 3x would be considered a monomial. It's a product of a number and one or more variables. 4x squared y would be a monomial. Something like 3x minus 1 is not a monomial because it involves addition or subtraction. So remember, a monomial is just a product. So this is not a monomial. Another example of something that would not be a monomial is something divided by. So this is also not. So anything again that involves multiplication, not addition or subtraction, not division. Now be careful, because if I have something like 2/3 x, that's multiplication by a variable and a number. It's when we're dividing by the variable. So this is okay. This is not. Okay, see the difference? When the x is in the denominator, it is not a monomial. If we have a monomial that is just a number, -34, this is a monomial. It's a number. We call this a special kind of monomial called a constant, because there's no variable portion, so it's constant. Okay? All right, so let's look at some of the rules. The product of powers. To multiply two powers that have the same base, add the exponents. And I know you've done this in pre-algebra. So a to the m times a to the n, this is our general rule, equals a to the m plus n. We're going to add the powers. 4 to the 5th times 4 cubed is 4 to the 5 plus 3, or 4 to the 8th. Okay, let's do a couple little examples. So if I have x squared times x cubed, we're multiplying the same bases. It's got to be the same base. And we're adding the powers, x to the 5th. Okay, let's make it a little tougher. 2x squared y to the 5th multiplied by 6x y to the 4th. Now we're gonna combine our like pieces. So we're going to do -2 times 6. We're going to do x squared times x. And we're going to do y to the 5th times y to the 4th. Remember that multiplication is commutative, so I can change the order. So -12, add the powers. There's an understood x to the first power on this one. So when you have just an x, don't forget to add it in as a second one, or as a single power. So 2 plus 1 is 3. 5 plus 4 is 9. So that's my final answer there. Okay, try this one on your own, and then come back to the video. So 3 times -2 is -6. A times a to the 5th is a to the 6th. B squared times b to the 6th is b to the 8th. And c times itself, or c times, there's nothing here, so we're just going to leave it as a c. Okay, so that's the multiplying a power times a power. Bases must be the same. Add the exponents. The next rule, power raised to a power. To find the power of a power, multiply. So a to the m to the nth is a to the mn. 5 squared and then cubed is 5 to the 6th. Let's look at why this one works. 5 squared cubed. To cube something means to multiply it by itself 3 times. Now if I go back to my rule from a minute ago, 2 plus 2 plus 2, or 2 times 3 is 6. Okay, so power raised to a power, we multiply. So let's do a couple of these. 2x cubed. Remember, the whole thing is being cubed, so we have to do 2 cubed and x cubed. 2 cubed is 8, so 8x cubed. 3x squared y to the 4th to the 5th. 3 to the 5th, x to the multiply, 2 times 10, 2 times 5 is 10, and y to the 20th. Okay, give this one a try. 1/2 x, well, let's switch up the variable. 1/2 a cubed b squared c to the 3rd power. Try that on your own. Okay, 1/2 to the 3rd power times a to the 9th, b to the 6th, c to the 3rd. 3 times 3 is 9, 3 times 2 is 6, 3 times 1 is 3. How do I do 1/2 cubed? Well, 1/2 cubed is 1/2 times 1/2 times 1/2, which is 1/8. So there's my final answer. Okay, the last thing is, oh, and I'm sorry, I jumped ahead. I did some powers of products already for you. The power of a product. I probably should have left these as just single ones, but I've already done a product for you. Hopefully that didn't confuse you because you've done these before. To find the power of a product, find the power of each factor and multiply. So again, each one of these is being raised to the mth power. So a to the m, b to the m, 7 cubed, x cubed. Okay, so let's do a few more. Let's see. 2x squared y to the 4th. Sorry, let's go back. All right, we'll try this again. Uh, 2x cubed y to the 4th to the 6th power would be 2 to the 6th, x to the 18th, y to the 24th. Okay, and again, we've done a few like that. I kind of combined these last two rules. I apologize. So this rule was just, what do you do when you have a power to a power? And this rule was distributing the power among a product. Now be very, very careful, and I want you to put this in your notes. A times b squared is a squared b squared. A plus b squared is not a squared plus b squared. Be very careful. This rule only works with a product. Only works with a product. When we have a sum, we cannot do this. This is a really easy trap to get into, and I want you to be sure to look at this carefully and realize that you may not distribute or raise a sum to the same power. It can only be done when it's a product, a multiplication problem. Okay, so let's go on. Simplifying a monomial by writing an equivalent expression in which each base appears exactly once, there are no powers of powers, and all of the fractions are in simplest form. So in order for something to be completely simplified, we have to make sure we've taken care of all of those things. So 1/2 x to the 6th y to the 4th all squared times, I'm going to do two parentheses here, -3 xy cubed squared to the 3rd power. Okay, so 1/2 squared. Actually, I'm going to change this to a 2 to make it a little easier for us. x to the 6th to the 2nd power is x to the 8th. Whoops, 12th, I'm multiplying. And y to the 8th. All of that's going to get multiplied by this big thing. Now I've got to work inside the parentheses and then out. So I'm going to leave my big bracket for a moment. Inside, negative 2 squared x squared y to the 6th. Okay, so I've distributed the power here. I've squared all of that. Now I'm going to cube it again. So let's go back and rewrite one more time. Negative 2 squared is 4. X squared y to the 6th cubed. And now I'm going to distribute that. So 1/2 squared is 1/4. X to the 12th, y to the 8th, times 4 cubed, x to the 6th, y to the 18th. We've got to keep going because we don't have the variable appearing once. So 1/4 I'm going to put next to 4 cubed. And 4 cubed is 64. We'll come back to that. And then I've got x to the 12th times x to the 6th. I'm combining my terms here, or setting them next to each other. Y to the 8th times y to the 18th. So 64 times 1/4. X to the, now we're adding, 18th. Y to the 26th. 64 divided by 4 is 16. X to the 18th, y to the 26th. You have to keep working and keep working and keep working until each variable term appears only once, and until any values that we have are in lowest terms, and so that we don't have any powers of powers left. Nothing is still being raised to a power. Okay, we'll do some more of these examples in class, and that's it.